The James Webb Space Telescope gives scientists an unprecedented vision of the universe, delivering fascinating findings that continue to amaze the scientific world. In a recent endeavor, its eyes are to be directed towards the heart of our Milky Way galaxy, which might answer, what processes drive the evolution of these massive, star-studded structures? And among them we might discover the secrets of how galaxies evolve, in the center of the Milky Way. The more we learn about our galaxy, the more we will learn about how other galaxies evolve throughout the cosmos. Welcome to Lab 360, it's time to explore. Since the day scientists first saw the bright spiral arms of the Milky Way, our home galaxy, they have been curious about the mysteries it might hold regarding the evolution of galaxies and perhaps life. But why the James Webb Space Telescope? Adam Ginsberg, an astronomer from the University of Florida claims, the center of our galaxy is challenging to observe for two reasons. First, the galactic center is completely dense, full of stars. Smaller telescopes struggle to differentiate between one star and another. And second, huge clouds of dust obscure our view of the galactic center from Earth. The James Webb Space Telescope resolves both of these issues, since it is a large telescope with good resolution and star separation capabilities. It can also see through the dust since it detects in the infrared spectrum. No other telescope has both capabilities. The JWST is uniquely able to see through these thick areas of dust thanks to its near-infrared camera and filter system, which allow astronomers to divide spectra of infrared light into wavelengths emitted by specific materials. Because the dust veils block out visible light wavelengths, those areas seem to the unassisted eye to be black voids. On the other hand, infrared wavelengths have the ability to traverse over and ultimately impact the JWST's detectors. When seeing galaxies in the early cosmos, the JWST can also take measurements at longer infrared light wavelengths. Due to the universe's ongoing expansion, the light from these galaxies has stretched, or redshifted, and is now traveling toward the red end of the electromagnetic spectrum. Another name for the process is the Doppler effect. Since infrared light has a longer wavelength and less energy than visible light, it is invisible to human vision. But what discoveries are to be made? For example, astronomers wonder what part does Sagittarius A, the supermassive black hole at the heart of our galaxy, plays a part in its evolution. It is previously known by astronomers that large, galactic black holes like this one develop primarily via feeding on gas that surrounds them in the form of accretion disks, which are plate-like structures. It is feasible to deduce a link between the growth history of Sagittarius A and the rate of star formation in the galactic center, because the existence of such gas is likewise an essential element for star formation. Helping researchers have a clear understanding of the number of stars forming and, consequently, the development rate of Sagittarius A, thanks to the planned multi-epoch studies of the galactic center. Sagittarius A is a quiescent black hole. Quiescent meaning a dormant black hole. According to Ginsberg, the study may also aid in improving estimates of the initial mass function, or IMF, or the proportion of massive to minor stars that originate. Astronomers can learn how much light star populations produce thanks to this function. This is crucial for research on galaxies that are too distant for astronomers to see individual stars in. Ginsberg says the IMF is tricky to measure, though, because the brightest stars go supernova in a very short time, so they're not around for long enough to measure. The galactic center gives us a nice opportunity to beat this problem because it contains many stars of all masses. It is also a different enough environment than the solar neighborhood that we learn something new about how to apply star formation rules to other galaxies. While we might be eager to peer into the depths of the Milky Way, we have some problems, especially human ones. Astronomers are being competitive over the use of this super telescope, and it has the highest oversubscription to use it, more than any telescope ever. When a proposal is put through, a group of specialists get together to evaluate the pertinent research. However, there are regulations that state you cannot analyze a proposal if you are on it or would benefit from it. Due to the fact that nearly all astronomers who research the Galactic Center want to be a part of the JWST Galactic Center surveying mission, this poses a challenge for the community that studies this region. The survey will make use of the currently operational Atacama Large Millimeter Array or ALMA, and Hubble Space Telescope, in addition to planned future telescopes such as the Roman Space Telescope, the extremely large telescope of the European Space Observatory, and Japan's Jasmine astrometry satellite. Data about the Galactic Center would be gathered by the planned multi-epoch study at intervals of 1, 5, and 10 years. Webb has already worked diligently with NASA's Fermi Satellite Observatory and the Neil Gorel Swift Observatory to determine the location of an exceptional gamma-ray burst. Webb's observations of the aftermath were critical in discovering tellurium in the cloud of particles that surrounded the merger. Other elements near tellurium on the periodic table, like iodine, which is needed for much of life on Earth, are also likely to be present among the kilonova's ejected material. It would have been hard to analyze this kilonova from the ground later, but the conditions were ideal for Webb's NIRCam and NIRSpec equipment to monitor this chaotic environment. The spectrum features broad lines that indicate the material being ejected at tremendous speeds, but one characteristic stands out: light released by tellurium, an element rarer on Earth than platinum. This is yet another significant milestone in the James Webb Space Telescope's remarkable mission. The collaboration of many telescopes on the ground and in space allowed scientists to piece together a wealth of information about this event as soon as the burst was first detected. It is an example of how satellites and telescopes work together to witness changes in the universe as they unfold. As I said earlier, the more we learn about our galaxy, the more we will learn about how other galaxies evolve throughout the cosmos. What discovery are you looking forward to? Drop in your comments below, and don't forget to subscribe to Lab 360, because together, we will explore.